In this video, I'm going to solve some logarithmic equations and exponential equations. These will be the same equations that I did in two previous videos where we used basically the TI-83 graphing calculator. Here it'll be no calculator. Well, we will use a calculator for basic computations, but not to solve. In that other video, we solved these same equations by graphing them and finding the x-intercepts, which led to the zeros of the function, which of course obviously led to the solution. So we have log of x minus 5 to base 3 plus log of x plus 3 to base 3 is equal to 2. So one of the best ways to solve a logarithmic equation is to try to get it down to one log if you can. So I'm going to use the properties of logs. So on the left, anytime you have the sum of two logs, you can write that as the product, the log of the product of those same values. So it's going to be the log of x minus 5 times x plus 3. And this is to base 3. But just keep in mind that when I write it this way, but basically, I guess I could put a bracket here because it's the log of all of that. It's the product. Now, once you have it as a log of some expression to base 3, in this case, equal number, that means that whatever you have right here, the log of whatever that is, in this case, it's the product. So let me just go ahead and write it as a product. So I don't have to take too long on this. It's the log of this product, so let's just multiply that out. That's going to give us x squared. And then we have a minus 5x there, and a 3x, that's minus 2x. And then 3 times minus 5 is minus 15. And that's going to equal to the base, which is 3, taken to this power of 2. So now we just write this as a quadratic with one side 0. So this will be 9 here. Bring that over to this side. And we get x squared minus 2x. Then bring the 9 over minus 9 and 15 is minus 24. And that's equal to 0. Now you just have a regular quadratic equation. You can solve it by factoring. I'll go up here. And that x squared minus 2x minus 24 factors into x minus 6 and x plus 2. I should say x plus 4. That's equal to 0. And then once you have the product of two factors, or whether it's three factors, it doesn't matter. When you have the product of factors equal to 0, that means at least one of the factors is 0, or they're all 0. They all could be 0. So you just set each factor equal to 0. Solve for x. So when is x minus 6 equal to 0? When x is 6. So x equals 6 is a possible solution. When is x plus 4 equal to 0? When x is negative 4. Negative 4 and 4 is 0. 0 times any factor is 0, so at negative 4 here. Those are the possible solutions. Notice I said possible because you still have to check. It's not going to be a solution if you replace the x in the equation by that number and you get the log of a negative. You can stop as soon as that happens. So if I put negative 4 where the x is right here, that gives me negative 4 and minus 5. That's negative 9. I don't even have to bother with the other one. This one is rejected. That one's rejected. Let's try 6. 6 minus 5 is 1. The log of 1 to base 3 is 0, because 3 to the 0 is 1. So that term cancels out. If I put a 6 right here in this next log, 6 and 3 is 9. The log of 9 to base 3 is equal to 2. That checks. So this is the only solution that we have. X equal to 6. That's your solution. Let's clear this. Here we have the log of 3x minus 3 minus a log of 4 is equal to the log of x plus 4. So what do I do here then? I'll do it right here. Anytime you have the log of the difference of two logs, I should say, difference of two logs, that's going to be the log of the fraction. In this case, 3x minus 3 over 4. I said the easiest way to solve a log equation is to write it as a single log, or it also works if you have a single log on each side. So because I had the difference of two logs, I can write this as the log of this fraction. And notice it doesn't have a base, so it's understood to be base 10. So I have the log of something equals the log of something. That means these two things have to be the same. Always going to be the same. So I'm going to come back up here and say that means that 3x minus 3 over 4 has to equal to x plus 1. So now, create a fraction, multiply through by 4. So I'm going to multiply both sides by 4. These 4 here's going to cancel, leave me with 3x minus 3. And multiply the other side by 4. 4 times x will be 4x. 4 times 1 is 4. And then we solve for x. So let's bring this 3x over to this side. That's subtracting 3x from both sides. So 4x minus 3x is x. And then subtract 4 from both sides. This one cancels over here. Minus 3 minus 4 is minus 7. X is equal to minus 7. That's a possible solution. But is it? All you have to do is plug it back in and check. And if on any of those terms you get the log of a negative, it's not going to work. Well, you can just start with this right side. I've put a negative 7 there where the x is. The log of x plus 1 becomes the log of minus 7 plus 1. That's the log of negative 6. So this one has no solution, no real solution. The empty set. Now let's look at the third one here. Clear this. And the log of x plus 4 is equal to log of 5x plus 1 plus log of 2. Again, no base indicated, so it means it's base 10. So this one's going to work kind of like the last one. Have the log of x plus 4 and on the right side I have the log, the sum of two logs, I should say, the sum of two logs. So the property tells me, for logarithms tells me, if you have a sum of two logs, that's the same thing as the log of the product of those terms. So it's 5x plus 1 times 2. That would give us 10x here. 2 times 5x is 10x. 2 times 1 is 2. And let's put parentheses on that. Now have a single log on each side. Log of this is equal to the log of this. That means that these two things inside there have to be equal. So all I have to do is say that x plus 4 is equal to 10x plus 2. And then we just isolate the x. Doesn't matter what side you put the x. I'm going to subtract x from both sides. That's going to cancel this x right here. And 1x from 10x is 9x. And whatever you do to one side, you have to do the other side. Now I'm going to get rid of this 2 so I can isolate the x term. So subtract 2 from this side, that cancels this. And then 4 subtract 2 is 2. They just divide both sides by 9. The 9's cancel out, and I get a possible solution is x is equal to 2/9. And this one we're just going to do a visual. Because if you do everything right, as long as when you plug it back in, you don't get the log of a negative, you're okay. That should work, assuming you did the algebra correct. So I put 2 9ths here where the x is, x plus 4. 2 9ths plus 4, that's positive, no problem there. The next one, 5 times 2 9ths plus 1, no problem, they're all positive, that's positive. And log of 2, that's positive. Everything that was done correctly, that should work. 2 9ths. And these are the same solutions that we got when we did it using the calculator and graphing each of these equations and finding the zeros which led to the solutions. Clear this. So we're dealing with exponential or log equations first, and then exponentials. So let's look at the next one. Solve each equation. So we have 3 to the x plus 1 is equal to 7. What I'll do here, I'm going to take the log of both sides. Now you can use log base 10 or the natural log. I'm going to use the natural log. So this is going to be 3 log of 3 to the x plus 1 equals to natural log of 7. And then we use properties of logs. Property of logs tells me that I have the natural log or any log to some number, some base or power. The power can become an exponent. So that means I can bring this out in front. Put parentheses there, otherwise you're going to mess it up. X plus 1 and ln of 3 is equal to ln natural log of 7. And remember that ln of 3 is just a number, so just divide through. Divide both sides by that number. So this is ln of 7 divided by ln of 3. We have to just solve for x. If I subtract 1 from both sides, the left side will give me just a plain x is equal to ln or natural log of 7 over natural log of 3 minus 1. Now that is the exact solution. So if the instructor asks you for the exact solution, you could give this answer. But if he asks you to approximate it, then you take out a calculator. It doesn't have to be a graphing calculator here. So we just enter ln 7 divided by ln of 3. So that enter there, okay, read that calculator, and then we subtract 1. And we get the 3 places, we run that out to 3 places, we get that x is equal to 0.771. Okay, you can run out to 2 places, 0.77, but that's the answer to 3 places. Okay, let's clear this, and we go to the next one. So we have e to the 2x minus 3e to the x minus 4 is equal to 0. This is an exponential equation. This has a special look here. Kind of looks like a quadratic equation. I could rewrite this so that becomes e to the x squared minus 3e to the x minus 4. So it's kind of like solving for an equation like x squared minus 3x minus 4. So what we'll do here is we'll factor this. Look, you would factor a quadratic equation. This is quadratic in form, except it's really an exponential in quadratic form. So I can write e to the 2x as e to the x, factor e to the x, and e to the x. And then now we want factors of 4. See, it's like you had x squared minus 3x minus 4. You want factors of a minus 4 to give me a minus 3 when we put them in here. Well, we can put a minus 4. and a plus 1. So we get two factors. Product is equal to 0, so that means that either one of the factors is 0 or they're both 0. So I simply set this equal to 0, and from the first factor I would get e to the x would equal to 4. And from the second one I would get e to the x is equal to negative 1. Now remember, e is a positive number. It's approximately 2.71. So you take a positive base and take it to any power, whether it's a positive or a negative. There's no way you're going to get a negative. Even if x is 0, e to the 0 is 1. It's not going to equal to negative 1. So the first one here has no solution, no real solution. So the only option you have is with this one. So e to the x is equal to 4. Kind of like the first one we did, that we took the log of both sides. Again, we could use log to base 10. But because you have an e, anytime you have an exponential with an e, the best thing to do is to take the natural log, because of what happens here. Notice, I take the natural log of the left side and the natural log of the right side. Because this space right here is e, we're saying e to what power is e to the x? Well, it's x. So anytime you have ln of the exponential e, it's going to be whatever the exponent is. So the exact answer to this one is x is equal to ln of 4. So if the instructor asks you for an exact answer, this would be your exact answer. If he asks you to give an approximation, then you would just take your calculator and compute natural log of 4, put it in parentheses, and hit enter. And you get .386. To 3 places. So if he asks you to round off, to 3 places, that's what you would give. 2 places, 1.38, and so on. But that's your solution. Okay, let's go to the next one. 2 to the x plus 2 equal to 6 to the x 2x minus 5. So again, this one, I'm going to take the natural log of both sides. So to save some time here, instead of rewriting this thing again, I'm going to say take natural log of this side and then natural log of this side, just to save some time here. So I have natural log of 2 to this power on the right side, natural log of 6 to this power. Again, property of logs tells me that if you have this type of situation, the exponent becomes a coefficient. Put it in parentheses, or else you're going to miss it. So that comes out in front, and this becomes the natural log of 2. Same thing on the right side. The exponent can become a coefficient. So get 2x minus 5 times the log, natural log of 6. So then you just multiply here. So here we just multiply ln of 2, so this becomes x ln of 2 plus 2. And at this side, multiplying by ln of 6, we get 2x ln of 6 minus 5 ln of 6. Now I could rewrite this 2 ln of 2 as ln of 4 if I wanted to, because this coefficient, it's just like an exponent becomes a coefficient, the coefficient can become an exponent, so I could actually rewrite this as ln of 4. But let's just go ahead and leave it like that. So we obviously want to solve for x. We want the x terms on one side. So let me go up to the top now. All I'm going to do now is I'm going to bring this term over to this side as an x, and everything that doesn't have an x comes to the other side. So that comes over here to this side. So I'm going to have x ln of 2, and the 2x ln of 6 comes over. That becomes a minus 2x ln of 6. And that's going to equal 2. So the 2 ln of 2 goes over, so that becomes minus 2 ln of 2. Minus 5 ln of 6. Okay. So x ln of 2 brought the 2x ln of 6 over, 2 ln of 2 went over, 2 ln of 2 went over to become minus ln of 2. So now what I'm going to do is I'm going to factor an x out from this. And that's going to leave me with ln of 2 minus ln of 6. So on the right side, I'm going to have the same thing, minus 2 ln of 2 minus 5 ln of 6. So all I'm going to do now is I'm going to divide on this side. This side is going to be divided by that, what I have there in the parentheses over here. And I'm going to get the value of x. So just to save some time here, I'll take the calculator out. So I'm just going to do this, the right side first. So I'm going to say minus 2 ln of 2. And that's minus 5 ln of 6. So I'm just going to hit enter, compute that, and then do the division. So hit enter, get that. And then I'm going to hit divide. And then I want to make sure I have parentheses here. Parentheses, and then I'm going to enter the ln of 2 close that parentheses there, minus ln of 6, close that parentheses, and then close the main one. So this is dividing the right side. Hit enter. And I left out the coefficient there. Need a 2 here. It should be a 2 right there. So let's clear this again. Let me do it again. So it's a minus 2 ln of 2 minus 5 ln of 6 and parentheses, hit enter. Okay, same answer there, and then I'm going to divide this, parentheses, ln of 2 minus 2 ln of 6 close parentheses, I make parentheses again, hit enter, and we get x is equal to 3.579. X is equal to 3.579 to 3 decimal places. Thanks for watching. We'll see you next time.